Welcome to our webinar this morning on the Ministry of Labour, Immigration, Training and Skills Development, the upcoming Northern Region Mining Initiative on hand-arm vibration. My name is Aidan Robertson with Workplace Safety and Prevention Services, and we're excited to host this session today with our various other health and safety partners here in the Ministry, CROSH, Workplace Safety North, OCOW, and IHSA. So just before we start the actual webinar content, just a quick couple housekeeping items. Let's pull over to these. So again, computer audio is recommended for this. We do offer the phone conference option available. You would see this in your meeting invite. Your microphone and camera will remain off throughout this session. We are recording this session so that folks can watch this afterwards as well and get all this fantastic information about this initiative. You do have the option to participate in some engagement throughout the session. You'll see the reactions up at the top of your screen if you want to use those. We don't have any polls in today's session, but you can submit questions using the meeting chat if you would like to do so, and we do encourage this. We'll say each presenter will talk about this, but we will be taking questions throughout. However, we will be addressing those questions after the content has been talked about. So we are going to let the presenters present, and then we'll address any questions that come through the chat afterwards. Again, if you do want to turn on live captioning, you do have this ability there within the accessibility features. Using the language and speech to turn on live captions. And again, if you do want to view the content in full screen, you can do so using the view function at the top there as well. We are collecting demographics information about who is attending these sessions. So if you would please participate in this, we're going to put this information in the chat here. I'm putting that there. This just lets us know who's joining these sessions, and so we can make sure these meet the needs of everyone across the province of Ontario. And I don't want to get ahead to that yet, but what I do want to do is transition back over and hand it over to Steve McDonald with the Ministry of Labour, Immigration, Training and Skills Development. Over to you, Steve, and I'll let you take control.
Excellent. Perfect. I will click that button. Good morning, everyone. Thank you, Aidan, for the great introduction. Thank you to all of you attending today, this webinar. So excited to bring this webinar to you all today to introduce this initiative on hand-arm vibration. I want to make sure I stress that this is a Northern Region mining initiative, so it is only being run in the North. Today's webinar is a joint webinar with the Centre for Research in Occupational Safety and Health, CROSH, Workplace Safety North, WSN, Workplace Safety Prevention Services, WSPS, the Occupational Health Clinics for Ontario Workers, OCOW, the Infrastructure Health and Safety Association, IHSA. So it's been a team effort getting us to this point. The goals of today's webinar are to raise awareness of the MLI-TSD Northern Region initiative for the mining sector, so that participants can understand the requirements under the Occupational Health and Safety Act and the mining regulations as they relate to the protection of workers from the hazard of hand-arm vibration. I'm going to refer to this as HAV moving forward. I may switch interchangeably, but HAV means hand-arm vibration. Increased knowledge of HAV exposure and health effects. Learn about the types of tools that can expose workers to HAV. Learn about control measures to reduce the risk to workers, and learn what resources and assistance are available to workplaces. We have a series of presenters. So there's myself from the ministry. I'm an ergonomist with the ministry. We have a subject matter expert, Dr. Katie Goggins, who will be speaking at length about HAV. And then Aidan Robertson, Steve Gore, Trevor Shell, and Peter Vai from the Health Safety Associations will have an opportunity to speak about how they can assist with this initiative moving forward. It's important to note that this presentation has been prepared to assist workplace parties in understanding their rights and responsibilities under the Occupational Safety Act and its regulations. It does not constitute legal advice, so please determine your rights and obligations under the OSHA. Contact legal counsel or refer to the legislation. So this is for information only. I do encourage questions, and I'll do my best to answer them for you today. So what is this HAV initiative? So it is an 18-month-long initiative focused in the mining sector within the Northern Region. Okay, so the MLI-TSD Northern Region. The goal is, to inform employers of the reporting requirements related to HAV. We'll talk about that. Ensure that employer risk assessments have examined and addressed the hazard of HAV. A very important piece, of course. Raise worker and supervisor awareness related to HAV and the potential health effects from exposure and the importance of risk controls. And then improve workplace hazard recognition of HAV. So the timelines, phase one currently occurring. Here we are today, some education and awareness. So the clock started ticking on April 1st. The initiative is 18 months, so going till October 2026. Once again, partnering with the HSAs that are listed there, CROSH, WSN, WSPS, OCAL, and IHSA. A lot of support from them. For this initiative, phase two is the enforcement phase. This begins November 2025 and lasts until October 2026. And this is where the MLI, TSD ergonomists and mining inspectors will be visiting mining operations in the northern region only. Okay, and I can't stress that enough. So why are we focused on HAV in mining? Well, occupational illness reporting to the ministry, there's been an upward trend. You can see there's a graph on the right side, and the blue line represents mining. And you can see there's a steep uphill slope occurring. You can see construction, there's been a decrease with a small blip in 21-22. Okay, but in the last 3 years alone, there's been more than 400 reported occupational illnesses related to HAV to the ministry. So once again, it's an alarming trend. The mining sector does have the most claims, once again, as visible on that graph. And in the past, the ministry's had about 501 claims between 2013 and 2020. So once again, just highlighting that there's been a real increase in reporting. So it's concerning, and we just want to make sure that we can do everything we can to protect workers. So where do we see hammer vibration in mining? Well, just a few examples here, of course. In underground, you've got jack legs and stopers and blowguns and things like that have air flowing through them that cause vibration. Surface plants, once again, jack legs are often used, or jackhammers, any kind of chiseling tools, blowguns as well are used often and can create a lot of vibration. In the maintenance world, air tools, impacts, ratchets, hammers, grinders, drills, blowguns, sandblasting guns, sanders, you name it, anything that's got air flowing through it is going to cause some form of vibration. Different tools, different exposures, and then electric tools such as drills, impacts, grinders, etc., can also be causing hammer vibration on workers and exposing them to that risk. So I just want to talk a bit about what an inspection visit would entail. So the ergonomist or inspector might ask to see or request a copy of the risk assessment that has been completed for the mining activities at the site. So there'll definitely be requests for that. If workers and supervisors have been trained to recognize HAV hazards and are aware of the control measures that the employer has in place to reduce their risk, awareness is a big component of this initiative. If any workers at the workplace have reported an occupational illness related to exposure to HAV, we may be coming in with that information beforehand, but there'll be definitely discussions about that. The employer to explain the measures currently in place to protect workers from the hazard of HAV, and to see workplace inspections or General Safety Committee minutes to see if maybe there is some vibration concerns that have been brought to the table for discussion. It would include observations of work tasks that utilize tools or equipment that produce HAV. So this could be surface operations or underground. Once again, depends on the circumstances of the mine and the type of mining that's being done. Also, any history of HAVs or other occupational illnesses related to vibration. There'll be a discussion with workplace parties to understand worker exposure to HAV. So talking to workers, supervisors, General Safety Committee representatives to understand what their concerns are, if any. And there may be direct measurement of the vibration exposure using specialized tools. Okay, so that's what an inspection would look like. It's really important that employers protect their workers from HAV. So I just want to go through some of the legislative requirements related to that. So it's important to know that all provincially regulated employers must comply with the Occupational Health Safety Act, and there's 25 regulations under the Occupational Health Safety Act, or the OSHA. However, hand vibration is not specifically addressed in the regulations. Okay, so there are some important caveats to the legislation related to vibration and how we would apply it. And that's basically that, every workplace, the OSHA, puts in place, worker rights and the ability to establish a strong internal responsibility system in the workplace, right? We all know about the worker's right to know, to participate and to refuse unsafe work. So making sure that those things are obviously in place. But specifically, Part 3 of the Act sets out duties of employers and other persons, such as workers, supervisors, owners, suppliers, constructors and licensees, and corporate officers and directors. Okay, specifically under that, Section 25 sets out the general duties of the employer. Okay, I'm not going to go through all these sections. I'm just going to go through a select few of them. There is a link there to some vibration resources, which there'll be lots of links to all this stuff later, but that is the ministry specific one. So under the Occupational Safety Act, like I said, Section 25, this section starts with an employer shall ensure. So just selecting a few of these important sections. 25(1)(b), equipment, materials, protective devices provided by the employer are maintained in good condition. So any tools or equipment that produce vibration, they need to be maintained in good condition. If they're not, obviously it can increase vibration exposure if they're not, maintained in proper order, or any attachments are not maintained. So we'll be looking out to make sure that the tools are maintained in good condition. 25(2)(a), information, instruction, supervision is provided to workers to protect their health and safety. Okay. It's really important that workers understand the tools they're using, how to use them properly, so there's not excess vibration occurring, or how they can minimize vibration exposure. Training to recognize when a tool is no longer, in optimal condition. This could be the rounding of bits and things like that that increases some of the vibration, especially when they're collaring a hole, right? You want tools that are in good condition, and that workers understand when they're not in good shape. And then understanding and training for workers on things like work rest cycles that can reduce exposure or risk, right? Under 25(2)(d), acquaint a worker or a person in authority over a worker with any hazard in the work and in the handling, storage, use, disposal, and transport of any article, device, equipment, or a biological, chemical, or physical agent. Okay, so you see any hazard. So vibration is a hazard, is a known hazard, and it's important that workplaces are doing what they can to make sure workers understand the hazard and how they can be exposed to it. They need to understand how they should be handling the equipment, storing the equipment, using the equipment, and how that can affect their exposure to the physical agent of vibration. And supervisors, they also need to understand the hazards of HAV, because they're the ones who can create a lot of change for workers, especially when you're going underground. The supervisors are the ones directing the work. So they've got the ability to facilitate any change. So they need to understand the hazards and what measures are needed to protect workers, and that they're being used properly. The other section is Section 25(2)(h). Many of you know this is our general duty clause, and it's a requirement for an employer to take every precaution reasonable in the circumstances for the protection of a worker. Okay, so I did mention that vibration does not have specific legislation. However, we would expect an employer to use reasonable precautions related to vibration exposure. Okay. Once again, there's a lot of resources that you're going to be linked to today that can help you build a program if you don't have one, or if you do, to enhance that program. It would be very beneficial for workers and supervisors, as well as the committee, to have as much information as possible. The other section is 25(2)(j), which is to prepare and review annually a written occupational safety policy and develop and maintain a program to implement that policy. Okay, so this is for workplaces greater than 5 workers, the requirement to have that policy, but of most importance is developing and maintaining a program. Okay, so this is where, we would want to see a vibration exposure control program, or some kind of program to protect workers. And what does that look like? Well, it depends on the type of work you're doing, right? A surface mine versus an underground mine is going to be very different. And there's different tools, as you saw earlier, that can expose workers differently to vibration. So it's very, very important. And that's why we need to, employers need to understand and how to protect workers, but they also need to be able to recognize what exposure workers may have, right? What tools are being used? What tasks are they being used for? How are they using them, etc. And it's important that there's determination and estimates of exposure for workers, such as the magnitude of vibration, the duration of exposure. Okay, so how much trigger time are we talking on these tools? It's all about understanding how much tools are used and how they are used. There needs to be consideration of the hierarchy of controls. Very important. I'll talk a bit more about that shortly. And then implement measures to reduce risk to workers. Okay. Another important criteria under the Occupational Health Safety Act, the OSHA, is section 52(2) and 3. This is the reporting of occupational illness. So injuries resulting from exposure to HAV are classified as an occupational illness. It's important that workplaces understand this. It is a physical agent. And once someone has a condition caused by HAV, such as hand or vibration syndrome, etc., this is irreversible and is an occupational illness. So where this occurs for a worker or a former worker that an employer has been advised that they have an occupational illness or a WSIB claim in respect of an occupational illness has been filed, the employer has a duty to notify the ministry and the Joint Health Safety Committee worker or worker rep at the workplace within 4 days. The union also would need to be notified. And then specifics of what must be reported are found in Ontario Regulation 420 from 2021, Section 3, Subsection 2. This information is required with the report. The name, the address, and type of business of the employer, the name of the worker, the nature of the occupational illness, the cause or suspected cause of the occupational illness, and then steps to prevent a recurrence or further illness. So very important that that information is provided. And the ministry, there's a link to it coming up, has a form that's already built on our website that can easily be filled out and sent in. Within the mining regulations, so Ontario Regulation 854 for mines and mining plants, there's some specific sections related to risk assessment. This is important for this initiative because we would want to see that employers are doing thorough reviews of HAV exposure in their workplace. So Section 5.11 requires that an employer conduct a risk assessment of the workplace for the purpose of identifying, assessing, and managing hazards and potential hazards that may expose a worker to injury or illness. Obviously, a very important point there. Subsection 2, a risk assessment must take into consideration the nature of the workplace, the type of work, the conditions of the work at that workplace, and the conditions of work common at similar workplaces. So, you know, there can be some comparison between parties of the type of work that they might be doing, but it's understanding the different types of work occurring at your workplace. And sometimes you have, you know, surface operations, underground operations, there's the mechanics who are doing their work. So all those entities would need to be assessed. The results of the assessment must be provided in writing to a Joint Health Safety Committee or Health and Safety representative, if any. Very important piece there, of course. In terms of risk management, continuing on, Section 5.2, Subsection 1, employer shall, in consultation with the Joint Health Safety Committee or Health and Safety representative, develop and maintain measures to eliminate where practicable or to control where the elimination is impracticable the hazards and potential hazards identified in a risk assessment conducted under subsection 5.1. Okay, these shall be put in writing and shall include things such as substitution, engineering controls, work practices, industrial hygiene practices, administrative controls, and PPE. So this is our hierarchy of controls, very important piece. So engineering is the preferred method, of course, and then substitution, right? Trying to substitute substitute any other kind of process as long as it doesn't introduce a new hazard. Engineering controls can reduce work exposure as well. These could be things like vibration dampening devices, things like that, but the workers don't need to do anything in particular because the tool might come equipped with an anti-vibration device or something like that. Work practice control, this is everything from scheduling to work procedures and methods that aim to reduce vibration risk. Training and supervision are key to this type of control. Industrial hygiene practices, so, you know, surveillance for early signs and symptoms of HAV is important. in that world. And then administrative controls are policies, training, vibration exposure control program, anything like that. And then PPE, which is our final line of defense, and the last thing when we can't apply any of the other 5 controls, it's all about putting PPE in place, right? And it has to be effective, it has to be appropriate for the hazard. Workers have to be trained in how to use it, how to maintain it, and it has to be worn. So it's very important that we consider all of these control measures when we're doing our risk assessment. And I kind of just went through 5.23, but personal protective equipment is the last line of defense. Lastly, the section 5.3, subsection 1, the risk assessment required by section 5.1 must be reviewed as often as necessary and at least annually. Okay, so if there's new hazards that appear throughout the year, then there'd be an expectation that the risk assessment be reviewed, or there's changes in tools, equipment, and technologies. Technology is always advancing. So if there's changes within the calendar year of your risk assessment, then you would need to do a review, but at minimum, at least annually. And when conducting the review, you want to look for new hazards or new potential hazards. Existing hazards or potential hazards that have changed would be reassessed, and the measures required by section 5.2 continue to effectively protect the health and safety of workers, right? So if there is an increase in occupational illnesses related to HAV, maybe there's something going on, right? Maybe it's the type of material that's being drilled in, and maybe there needs to be changes or something like that, just as an example. And then lastly, section 5.3, subsection 3, without reading all of that, basically making sure that these assessments are put into writing, okay, for any of these new hazards that may be found in a workplace, or any potential hazards. So those are the expectations from the legislation, and I'll ask you to submit any questions in the chat and we'll answer them later. But I am going to pass the floor to Dr. Katie Goggins, who's the senior scientist at the Center for Research in Occupational Safety and Health, CROSH. So Dr. Goggins, her research interests focus on the role of biomechanics, human factors, and ergonomics on industrial health and safety and occupational disease. More specifically, she researches the influence of standing foot-transmitted vibration exposure on workers. She has 13 years of experience in evaluating field exposures to whole body, hand-transmitted, and foot-transmitted vibration. Dr. Goggins is also an adjunct professor in the School of Kinesiology and Health Sciences and the Barty School of Engineering, and a part-time professor in Safety and Environmental Studies at Cambridge College. Katie is also a Canadian Certified Professional Ergonomist, CCPE. Dr. Goggins, take it away. Thanks.
Hi, everyone. Thanks for that introduction, Steve, and thank you for having me this morning. So today I'm going to take this opportunity to talk about the health effects, and more specifically about some possible control strategies for occupational hand-arm vibration exposure. So like Steve mentioned, if you have any questions that are specific to anything that I am discussing at this point, please put them in the chat, and I have left time to answer any questions at the end of the presentation. So I'd like to start by trying to put the occupational disease risk for hand-transmitted vibration into perspective for mining. And so one of the hardest things to find in the research is actual documented cases of occupational disease. Because if you just look at the workplace claims that were covered or awarded, those numbers could be severely underestimating occupational disease risk, right? And so fortunately for me and everyone here, recently, Workplace Safety North had published their work with the Occupational Cancer Research Centre, so OCRC, in Ontario to rank the occupational disease risks in mining. They used health data from the Ontario Cancer Registry, OHIP, and hospital records. So what I'm presenting right now is from 1964 to 2020, but we've also updated it, and there will be a newer publication for the different risks. Before we look at this together, it's important to note that in this case, not all diseases are studied or recorded in Ontario's occupational disease surveillance system. And so something like on the bottom here, the noise-induced hearing loss, that is the leading occupational disease in most industries from WSIB, is noted separately here at the bottom. So I've broken these down into 4 categories for us to quickly review here, but there are the cancers. So we have laryngeal, lung, oral, colorectal, pancreatic, and leukemia, and non-Hodgkin's lymphoma. Then there are diseases specific to the lungs. So I know I put lung cancer with the cancers, but there's also the silicosis and idiopathic pulmonary fibrosis and COPD, or chronic obstructive pulmonary disease. So these are typically from prolonged exposure to some kind of airborne contaminant. And then there's the heart and blood flow problems causing acute myocardial infarction or heart attack. And finally, what we're here to talk about today, obviously, the effects of hand-transmitted vibration exposure. And so carpal tunnel syndrome and Raynaud's syndrome and noise-induced hearing loss are all on the list of the top occupational diseases in mining. Today, I'm going to define the anticipated symptoms of these types of exposure and where the research is at for applying the hierarchy of controls to these situations. I'd like to touch on a little bit of my foot transmitted vibration research quickly at the end, and then I'm going to finish up by discussing what we're currently working on, the research that we are doing regarding hand and foot transmitted vibration exposure, and just possible opportunities for participation. So it's one thing to list the occupational diseases, obviously, but what are the health effects and the symptoms for the actual worker? So you already saw that carpal tunnel syndrome is within the top 2 occupational diseases in mining, aside from noise-induced hearing loss. But what is carpal tunnel syndrome really? It's nervous system damage. At the core of it, it's nervous system damage. So in this image of the hand, the blue ligaments along the wrist, that's the transverse carpal ligament, and the yellow lines, they're the median nerve. Now, if we look at the cross-section views here, the top one shows a normal, healthy carpal tunnel. There's no swelling, the median nerve is not compressed. The bottom cross-section shows what happens when there's inflammation on the carpal ligament or the wrist. So this compresses that median nerve there. If the median nerve becomes compressed, you can expect numbness and tingling in the thumb and first 3 fingers. This can also result in a reduced sense of touch and temperature. So nervous system symptoms are typically first with hand-transmitted vibration. So often your workers will have numbness the same day as they've been working. Damage to the vascular system or blood flow is best known as vibration-induced white finger. So this is the episodic blanching or whitening of the fingers. It's the characteristic vascular sign. When our vascular system is healthy, we have normal digital artery blood flow. The blood is free to flow properly to our fingertips, like you see in this image. But when the arteries have scarring, there are many factors that could cause this. But in our case, we are reviewing the effects of repeated vibration exposure. The scarring causes the constriction of the arteries. And this will reduce the blood flow to our fingertips, and that's what's going to be causing that blanching or whitening at the end of the fingertips. Or in real life, without the cartoon version here, the whitening here of the fingertips can look like this. The main trigger for the symptoms is often exposure to the cold, but it can also be triggered by localized or general body cooling in otherwise warm environments. And so although the vibration exposure can cause the symptoms, it does not necessarily precipitate the symptoms once we're already in the phase of the blanching attacks. And the third system that could be affected by repetitive hand-transmitted vibration exposure is the musculoskeletal system. So here we're looking at tendinitis, which is a painful inflammation of the tendons. Keep in mind how small the hand and their muscles are. There's muscle fatigue here. It can also result in reduced grip strength and manual dexterity for the workers. When the tendons become inflamed around the nerves, things like contractures can happen. So contractures are that inability to straighten the finger. Workers can have any combination of the neurological, vascular, and musculoskeletal symptoms, so all 3 systems. And this would be referred to as hand-arm vibration syndrome, or HAVS. So how do we actually measure occupational exposure to hand-transmitted vibration? I'm just going to go through this very quickly, keeping in mind that this would be fully a course. This is taught at a master's level. And so just a very brief overview here, very quickly. There isn't a Canadian specific standard. And for the most part, we do end up defaulting to ISO standards, whether we're using the ISO standard directly or ACGIH standard, it will automatically suggest to use the methodology for measurement outlined in the ISO standard. And so in the hand arm vibration case, what we're talking about is ISO 5349-1, mechanical vibration, measurement and evaluation of human vibration, human exposure to hand transmitted vibration. So generally, there are 4 steps to taking a hand transmitted vibration measurement. And so you're going to follow the ISO standard guidelines for setting up the weighting factors and filtering up front on your accelerometry. You're securing the triaxial accelerometer to the tool, recording vibration for a sufficient duration to be representative of the vibration exposure. And that's that trigger time that Steve was talking about, and just making sure that we understand that fully for the workers. And you're instructing the operator to operate the tool or equipment according to regular operating procedures. And so I'm just going to highlight some things to look out for and why hand transmitted vibration measurements can be difficult to capture. So the first thing here is the contact points with the tools. They can really vary. It can be difficult to attach the accelerometer to hand tools without getting in the way of the worker. We also have to keep in mind here that the wires cannot interfere with the worker operating the tool. And so in cases where it's something like a steering wheel and there's going to be turning of the steering wheel, the wires can end up around they can end up wrapping around the steering wheel. And so it's just things like that. We have to be very careful. We do not want to interfere with the worker's ability to do their work. And so here this is just a demonstration of the HVM 200, and it's on the impact plate here. And so this one is attached directly onto the tool with the data logger directly on the forearm. So the wire, you can see a little bit of the wire here. This is a pretty simplistic scenario of, okay, so they're doing this. They just operate in this singular direction. It's a very easy grip to put an accelerometer on. And so this would be an instance where the wires are not getting in the way and the person can work. So some things that have happened on mining equipment. So research has been conducted to compare tool attached, which is that top right, and hand attached, which is the bottom right, accelerometry on, for instance, a jackleg drill here. So this study is really important because it shows that the choice of accelerometer placement affects the measurement result. So there was a significant difference in vibration magnitude measured by the tool attached accelerometers compared with the hand attached accelerometers. So this difference is likely to vary depending on how workers grip the tool handle, and a misclassification of exposure can occur if workers grip the tool handle in a way that makes the accelerometer lose contact with the vibrating surface. So we do need to consider these differences when we're taking hand transmitted vibration measurements. It's not as simple as a whole body vibration measurement where this is a seat pad and the person's seated on that, they're operating for extended periods of time. Here, we often with hand tools, the operator is moving around a lot. They're gripping that differently, using it differently. And it's just making sure that we do capture as accurately as possible the exposure. So now I'd like to look at some of the levels of hand transmitted vibration exposure. So what are these common exposures? But before we start looking at them, we do need to quickly review the exposure limit values. So the ISO standard uses a single value where symptoms are rare for exposures below 2 meters per second squared. The ACGIH has an 8-hour equivalent total value of 5 meters per second squared that if the worker remains under it is believed that they won't have hand arm vibration symptoms. And the EU directive, just for comparison, it uses the action value of 2.5 and a daily exposure limit of 5. So a little difference here. We can look at some examples of hand transmitted vibration exposures. So the equipment names are on the left here with little icons of them on the right. The minimum is the light yellow bar on the left. The 25th percentile to 75th percentile is that orange bar in the middle. And the 75th percentile to the maximum is the light yellow bar on the right. So if we can impose the vertical lines with the lower and upper action or acceleration limits of those standards we just reviewed on the figure here. And you can quickly see that all of this equipment operates within or well above the upper limit of the health guidance caution zones. So with every piece of equipment here, the exposures are well above that health guidance caution zone value. Any worker operating this equipment for 8 hours is at risk of halves. This really means we need to be careful with how long we let workers operate this equipment and how we apply the hierarchy of controls to this equipment. Finding hand transmitted vibration measurements on mining equipment, it can be difficult. So normally we're doing seated. In the literature, there's a lot more seated whole body vibration measurements. But here are the results of a study that did take 40 hand transmitted vibration measurements on these pieces of equipment. 70% of the equipment exceeded the 8-hour health guidance caution zone value of 2.5. Operators were 7.6 times more vulnerable to pains or discomfort in the left shoulder and wrist compared to their non-exposed workers or controls. So in this case, it was office workers. And risk for MSD, musculoskeletal disorder development, was higher than the control group and 9.4 times higher for those who identified as tobacco users. In 2021, there was a study conducted specifically on jacklegs with a traditional handle on the left you see here and an anti-vibration handle on the right. The vibration total value accelerations are displayed here on the vertical axis for you. For the traditional handle without a glove, traditional handle with a glove, an anti-vibration handle without a glove and with a glove. The dotted line is the 2.5 meters per second squared, the action value. This solid line here is the 5 meters per second squared, the limit value, according to ACGIH standards. So you can very easily see that jacklegs, regardless of the anti-vibration handle or gloves, operate at a high vibration acceleration value. So what are the control strategies for hand transmitted vibration exposure? We're going to try to apply the hierarchy of controls to look at some of the possibilities here. And so for elimination, obviously it would be ideal to have remote operated mobile equipment complete the task or automate the process. We're not entirely there yet, but eventually that would be the ideal scenario where the person is actually operating remotely. They're not touching any of the vibrating equipment or drilling equipment. And so they're able actually just to remove that exposure entirely. Here's a case with the result of using a different process. And so in this example, instead of using small pneumatic breakers to take the concrete wall down, the wall was cut away from the building using stitch drilling. So exactly like it sounds, overlapping holes here. Using a diamond drill that was held onto the wall with the clamp. So you can see the workers would clamp it on, it would drill without them actually touching it. So by changing the process, you can see the results in the table there. The operator exposure became negligible. Previously, they would have only been able to operate for 26 minutes before reaching that daily exposure value. As a bonus, this did reduce the noise exposure and dust debris in the building as well. The cost was estimated to be 50% more than the cost of using pneumatic breakers on the same job. So a little bit of a downfall with the cost, but probably worth it in the end. As far as substitution controls for hand transmitted vibration, we would again pick equipment with lower hand transmitted vibration exposures, which requires a purchasing policy with the selection specifications of the desired exposure levels. So we also need to be educated on how to pick different equipment. So in this case, low vibration angle grinders were introduced for welding and metal fabrications. So the results from the table, the vibration magnitudes are lower. In extended testing on real jobs in the yard, the new grinders produced an average vibration magnitude of 3.5 instead of 7, so basically having that. So taking an operating time of 1 hour and 17 minutes to reach the exposure level, now it's 5 hours and 7 minutes. The tool was also much lighter, and so the workers had said that was easier and less tiring to operate. The cost of this change was that this angle grinder is approximately $1,000 more. The research and development of the new SOPs and implementation did take a month, and there were necessary alterations to the air distribution system that involved a more significant expenditure in this case. When we're trying to select machinery to purchase, there are ergonomic considerations. So we'd like to think about the machine weight, the noise and dust production, machine efficiency and suitability for the task, the handle design and comfort, the grip and feed forces that are needed to operate that piece of equipment, the ease of use of handling, the warmth of the handle grips, and from compressed air tools, we need to look at the direction of the exhaust, and it should always be away from the hand grip areas. For engineering controls, we can provide auxiliary equipment, which reduces the risk of injuries caused by vibration. So this can include anti-vibration handles and machine balancers. You saw that this is not always extremely effective, as with the jackleg, but there is a possibility. We can choose ergonomic work equipment with a more ergonomic workspace design. And ideally, we're continuing to work on modeling the hand-arm vibration response to develop effective controls without further exposing workers or laboratory participants. So this is really the research-dependent piece there, where we're using modeling technology to be able to do that without actually doing anything or stop work. As for administrative controls, so equipment maintenance programs are a must. Finding suitable and sufficient information and training for employees is really important. Limiting the duration and magnitude of exposure as much as possible with break scheduling or job rotation is obviously an option here. Health and medical surveillance and protecting the employees from cold and damp conditions is really significant. And so this is because our body will already start that vasoconstriction of the arteries in our periphery or the hands and feet when we're cold. And so automatically we're already reducing blood flow to the periphery. For equipment maintenance, here's a quick example of what happens. So when 5 bushings on the chainsaw that cost about $10 each are replaced, it took about an hour to do. And so you can see the bushings on the bench there. The vibration magnitude measured with the same operator cutting the same piece of wood as before was reduced to 5.4 instead of 9.7. So this would allow for 2 hours of use in the day before reaching an exposure limit. The operator had more control of the tool and found it more comfortable to operate instead of 40 minutes. Again, nobody's operating the chainsaw for 8 hours without reaching the health guidance caution zone, but you are just changing the amount of time before we're reaching that first significant value. So there are very specific methods of quantifying the symptoms of hand-transmitted vibration exposure. Here's an example of a modified Stockholm sensory neural staging system. And so it really helps narrow down which symptoms. Is it the numbness, tingling? Are we talking about weakness, clumsiness, or pain are present and at what level? There are questions about how the symptoms are provoked, when they've occurred, the frequency, duration, and severity. There are also specific methods for scoring vascular or blanching damage. So if we look at the right hand on the left of the screen here, you start the scoring from the thumb. So here the right hand has a blanching score of 0, 1, 3, 0, 0. On the left hand, again, starting from the thumb, this would be a score of 0, 1, 3, 6, 6. So often these are methods used by occupational physicians. So it's definitely not something that we all need to be specialists on, But it's just something to keep in mind if you ever see a blanching score reported for your workers or anything like that. There are methods where the occupational physicians are doing this. And finally, for PPE, there are anti-vibration gloves, but they have very limited effectiveness. And so we can look at the vibration transmissibility results of 7 work gloves. So as you see in the photo here, this is the table of the transmissibility results at a frequency range of 31.5 to 200 hertz. The glove ID and major anti-vibration AV material there of the glove are recorded in the first 2 columns. Then there were 3 force conditions tested with different grip and push force combinations. So under the first force here, 2 gloves, B and E, reduced the transmissibility by 12%. For the second force, the best glove, E, reduced the transmissibility to the hand by 9%, and force 3 by 8%. We can look at the same table. So now the frequency range has changed to be higher frequency. So we're looking at something with exposure range here of 200 to 500 hertz. 3 of the gloves, B, C, and D, actually amplified the vibration to the wearer. So the wearer actually would have been better off to be barehanded in this case. And at higher frequencies, glove A performed the best in all force conditions with a 9 to 19% reduction of the transmission. So this study just demonstrates how glove selection is extremely dependent on knowing the exposure frequency. Otherwise, you can end up making things worse for the worker if the glove does not match the exposure frequency. I'm going to very quickly touch on foot transmitted vibration, as it is also my specific research area. But we're going to start with just the symptoms of foot transmitted vibration exposure here. They parallel those of hand transmitted vibration exposure. So the first symptoms are normally neurological, numbness and tingling in the toes, and reduced sense of touch and temperature. Then again, we have the vascular symptoms. They're illustrated on the right as a condition term, vibration-induced white foot. During a toe blanching attack, the skin of the affected areas generally changes color. So over the course of the attack, initially the area goes white as blood flow reduces to the area, and then the skin can turn blue or purple. And then finally, as the blood flow returns, usually within 15 to 20 minutes, the skin becomes red. So this kind of vascular damage and loss of circulation can occur in as little as 2 to 3 months of prolonged exposure to vibration. And so eventually what could end up happening without any intervention, the damage can be permanent, and necrosis can occur. So this is that full loss cell death here that you see on the nail beds. Then finally, there are also the osteoarticular symptoms. And so this is the bone and joint damage or muscular fatigue of the lower limb, potentially leading to like slip, trip, and falls. So the biggest problem with foot transmitted vibration exposure and vibration-induced white foot is the pathology. When we're talking about how the arteries of the hand can become thicker from repetitive vibration exposure, thanks to our sympathetic nervous system, the exposure does not need to be direct. So our sympathetic nervous system can cause vasoconstriction of the arteries in our periphery in response to vibration exposure. And I'm going to explain this a little further in the next slides. But let's look at these plasmography results. So to my knowledge, the literature on vibration-induced white foot without the corresponding hand-arm vibration syndrome is limited to 2 published case studies. So in this case study, the worker was exposed to hand-transmitted vibration, but the cold provocation test resulted in damped toe waveforms only. So a diagnosis of vibration-induced Raynaud's phenomenon in the feet was determined based on exposure history, compatible symptoms, a negative workup for other secondary causes of Raynaud's phenomenon, and then obviously these plasmography results. And so you're probably thinking, you know, Katie, you had me until that slide. So to simply put this, The worker could be exposed to hand-transmitted vibration and have vibration-induced white finger or vibration-induced white foot, or both. They could also only be exposed to foot-transmitted vibration and have vibration-induced white finger or vibration-induced white foot, or both. And then finally, they could be exposed to both hand-transmitted vibration and foot-transmitted vibration and only end up with symptoms in their hands, feet, or both. So this, of course, can make the symptoms or the cause of the symptoms really difficult to isolate. And one of the things is, unfortunately, our attempts to reduce hand-arm vibration have created the exposure to foot-transmitted vibration. So we have been taking the vibrating tools out of the hands of underground workers, and instead we're kind of creating equipment that we stand on to operate. So the contact points associated with occupational exposure to vibration have changed. So as illustrated here for jumbo drills, bolting, and raised platforms. With the jumbo drills, so here's just a summary of the literature that's been reported for mining for foot transmitted vibration exposure. And so for jumbo drill operators, 3 out of 5 miners report moderate to severe pain, aches, or discomfort below the knees. A case report of a 54-year-old miner with the chief complaint of blanching and pain in the toes was for a bolter here. And another study found that 6 out of 27 miners displayed Raynaud's phenomenon in their feet while they were using drilling platforms. The real problem is that foot transmitted vibration exposure is under or never reported. So even in this survey from Commonwealth of Australia in 2009, it's a large survey. It included 1,358 workers exposed to vibration. There's no opportunities for them to suggest that they were exposed at the feet. And so what are we working on then? So what are we researching? How are we trying to help? One of the things that we have been trying to do here is we've been trying to complete a hand and foot transmitted vibration prevalence study. We've been hoping to travel to these locations in Northern Ontario, depending on the interest in participation. So, but ultimately, I'm just going to outline the study has 3 parts. The first part is the symptoms prevalence questionnaire. Then there's a training module for workers and some clinical measurements afterwards. And so what does that really look like? The first part with the symptoms prevalence questionnaire is I've designed a 9-page questionnaire with sections on personal demographics, relevant medical background, work occupational history, workplace exposure details. There's symptoms sections for vascular, sensory neural, and numbness in the hands and feet. So you can see a little snapshot of how we'll be asking workers to shade the different areas of their hands and feet that are affected. And so this will be the first survey that specifically focuses on symptoms in both hands and feet. When workers have to go for their assessment, it's a 42-page questionnaire. So we've reduced that substantially. I know 9 pages seems like a lot, but eventually it would be a 42-page questionnaire. Then there's the training module. And so I'm just showing the brochure here that goes along with a video training module on hand transmitted vibration exposure. And so all of this information on the health risks for the workers' hands, feet, and hearing are highlighted in the training module. And so the training video is about 10 minutes. There's a pre kind of knowledge questionnaire. What did they know about this before we did this? And what do they know about it afterwards? And so this is that research element of making sure that the training actually targets the knowledge that we would like the workers to know. And the last part of the research, it's going to include a few clinical measurements with grip and pinch strength, the Purdue pegboard assessment for that one's for manual dexterity, and thermal imaging of the hands and feet. So where you can see in this image here, someone with full circulation to their fingertips is on the left. And same conditions, someone with more limited circulation to the fingertips here is on the right. Ultimately, these clinical measurements are absolutely not to be doing diagnostics. It is not a diagnostic experiment. It is not to give workers a diagnosis. They are to give workers a flavor for things they may have to do as part of their assessments in the future. So obviously cold provocation tests, there's actual nerve testing with it's much more advanced testing here. This is just the more basic clinical measurements that you may see. So from the research side, this thermal imaging, it's to determine if there's a meaningful correlation between the symptoms the workers are shading on that questionnaire and the potential circulation differences from the thermal image of the hands and feet. And so that part is, again, non-diagnostic, but just to actually see if there's any significance to just doing a thermal image, or if workers can accurately shade their own symptoms. So I also partnered with CREA-MSD to develop effective visual summaries of most of the information that I presented here for you today. So the CREA-MSD website will now host a poster series specific to vibration exposure. There are general posters, like the one you see here, where vibration is defined and the types of vibration exposures in a workplace are also summarized. The images have identified, so the primary contact point is in yellow with tools. So throughout the entire poster series, that would be in yellow with the primary exposed body segments highlighted in orange. And so whether it's for hand, arm, foot, or whole body vibration, they have been identified in the poster series. There are hand-arm vibration awareness posters. So they summarize the potential exposures in different industries. And then also on these posters, all of the symptoms information I presented earlier today have been summarized with another infographic, just so that you would be able to display this in your workplace or have it available to you for use. Then from there are hand-arm vibration management posters as well. So they identify the different steps in the hazard identification process for everyone who's involved in which steps, and kind of what to expect there. We've also summarized the risk assessment. And so from the quantifying the risk here, talking about which methods, which standards to use, and the values that you're looking at for comparison. So this is important when we're talking about selecting equipment, for instance, or selecting new tools, and just knowing that when you're looking at a data spec sheet for a piece of equipment, that the types of values that you're looking for, or which ones you're looking to be closest to. And so all of that information is also summarized on the management posters. And so I'd just like to briefly summarize what we've looked at together this morning here. So hand-arm vibration can have any combination of neurological, vascular, and osteoarticular symptoms for the worker. So remembering it can be one or all three. When it is all three, you'll hear that referred to as hand-arm vibration syndrome. When it's neurological, typically it's carpal tunnel. When it's vascular, it will be vibration-induced white finger or foot. Hand, arm, and foot transmitted vibration symptoms are similar. They can occur simultaneously or individually. Hand arm vibration exposure in mining equipment has been measured above exposure standard values. So remembering that it can be difficult to measure because of the wires, the differences in on-hand and on-tool measurements. And so just keeping that in mind. Controls must often have to involve multiple levels of the hierarchy on a case-by-case basis. It can be really difficult just to suggest a singular control, just because this type of equipment does operate at a very high vibration level oftentimes. So it's just something to keep in mind. We would like to always apply multiple levels of the hierarchy. And so I put the information for the CROSH hand and foot transmitted vibration prevalence study here. If you would like to reach out about that or you're interested in that, it's definitely right there for you the link or in the URL, the QR code, or you can reach out to the CROSH Tech email. And I've also added here the CREA-MSD CROSH vibration posters. So I didn't put all of the posters, obviously. There's a whole bunch of information there. It is all hosted on the MSD Prevention Guideline for Ontario website. And so if you have any interest in all of that material, it's free to you on that website as well. So I'd like to thank you for your time today, and I'm going to welcome any questions on the information that I presented at this time.
Thank you so much, Katie. That was awesome, and I hope such great information for everybody here. And I hope everybody's starting to see with this initiative the level of information and support, and just the ability to participate in even ongoing research about this topic that can be done as part of this, all in support of figuring out ways to identify these exposures in the workplace and reduce those as well. If there are any questions, please by all means type them into the chat there. I don't see any so far. I think everybody's floored with the amazing information. And again, we are going to have a couple minutes for questions after we just go over a few other resources here. So if there's anything on your mind, we are going to show a couple other things here. Again, additional resources that are there to support you with this initiative. And if you do have any questions as we keep going here, even if they're still for Katie, wrap your head around that complex information. My favorite there was the simplicity of the hand and foot slide. I really like that graphic there. So I'm going to change back over to 1 second here. So again, thank you so much there, Katie. And again, carrying on with that idea of what's out there to support you in your workplaces in addressing what needs to be addressed with this initiative. Actually, sorry, we do have one question here before I get into this stuff, Katie. So any insights into why the trend was towards the left shoulder and hand being the most commonly injured? I think we're going back to one of those symptom prevalence studies. So yeah.
Okay, yeah. So in that case, a lot of that equipment was actually, they took the simultaneous seated measurement with the hand and arm vibration measurement. So oftentimes when there's joystick operation, it will be with the right hand, or a lot of steering wheel operation is with the right hand. So that actually will take the elbow off of the armrest. And so the left arm will oftentimes be resting on the side of the vehicle or the armrest. And so you can see sometimes there will be differences in the shoulder injury or discomfort, pain, based on where they're resting their arm. Yeah.
Excellent.
Good question.
This is a simplistic comparison there, but I'm thinking of driving down the highway in the summertime and you get the sunburn on the left side of your arm.
Yep, that's exactly it.
Another question here. Awesome. We stimulated some discussion here. Thank you so much, everybody. So what types of precautionary information regarding vibration and recommended protections is currently being provided by tool and equipment OEMs?
Okay, so this is a great question. There's not a lot of vibration specific information. A lot of times it is the ergonomic information is provided of the handle controls, diameters, things like that of the hand arm equipment. And so when you are looking at a specification sheet, or when you're asking a manufacturer or looking for the OEM specific information in the sheet, there can be vibration exposures documented. So keep in mind, though, that this would be the cleanest, nicest use of the equipment. When they're testing that, they're testing the vibration in the best case scenario, oftentimes not in obviously a mining working scenario. So it's one scenario where you can look and see on the data spec sheets if there's something published for you to start with. So determining whether there's a difference in a brand of what we went through, like an angle grinder, was there initially a difference in how that's working? And so that can be found sometimes in the spec sheets before you're doing the purchasing, but there's not a lot of information for vibration stuff provided. That's a great question.
Yeah, and I can speak that too. Having done lots of the exposure screenings, trying to use that and find that manufacturer information, you find yourself looking for resources in various jurisdictions, some in which it's reported, some in which it's not. So yeah, absolutely good question. But again, to your point there, it really does depend on the situation in which you start to use that tool. As soon as you're out of the lab, they're using it, different bits, different surfaces. Absolutely, the exposures can be different. Thank you. And again, any more questions here, please keep them coming. Thank you there, Katie. That was awesome. So again, Crush and the rest of us in the Ontario Health and Safety System here, we're here to support you with this initiative. We want to help people wherever you are at with your risk assessment, program development, control strategies, and overall consideration of this hazard and risk in your workplaces there. Again, I've broken out. We have various supports available to you. You can see on screen here, you should be able to click it there. We've compiled as many resources as we could find without over inundating you with information into some various buckets. If you're looking for providing, information about this hazard to your workers, hey, these are the signs and symptoms you should be on the lookout for. Please report these symptoms if you're experiencing to us so we can address these at the earliest stage. If you're looking for information on OC illness reporting requirements with the ministry to make sure that those are fulfilled, that is all in there as well. If you're looking for risk assessment and control support, again, Katie went over there all the ability, the various standards at which we can measure and screen or directly assess exposure to. You would have seen that HVM 200 device in one of the images there. If that's a level of support you're looking for with regards to risk assessment, that's something that can be done. I'll let the other HSAs are here as well. By all means, please, folks, come on the screen here, show yourselves, and say hi. We're all here to support you with this initiative. You'll see our contact information is there. Katie's, IHSA's, OCOW's, mine with WSPS and WSN's there as well. Please reach out to us for support with this. We're all in this together here. We want to make sure that workplaces get the support that they need here, wherever you are at. So again, you heard Steve there at the front end talking about the requirement to do some more diligent risk assessments for this particular hazard in the workplace. There's plenty of resources available to support you in that, whether that's through participating in research with Katie and getting some screening or assessments done. There is directions for you to take here, regardless of where you're at. Again, please, and I can share very quickly here. I have the screen just so you can see what it looks like. This would be the landing page. So if you do open up that link there, we've tried to compile a range of resources here for you. And again, everybody. So again, you can see, including the resources that Katie was drawing reference to there as well. And again, any support that you require, we're wanting to make sure that workplaces get it. So I want to give an opportunity to have the HSA partners introduce themselves as well. If you want to come off on camera there.
For sure. So I'll start. I just wanted to thank everyone involved in this webinar, the planning stages, and thank you, Dr. Goggins, for that very valuable information. I just wanted to note that at Workplace Safety North specifically, we don't have any certified ergonomists on staff, but we do have folks that are experienced in the assessment piece and screening. So we're happy to partner with the HSAs should an ergonomist be need to be involved. And obviously, mining is a little bit more of our bread and butter. So there'll be definitely some partnerships if you reach out for any help, and we're happy to help. And I think it's going to be a great initiative, and looking forward to hearing from all of you for support.
Hang on. Thank you, Steve. Yes, looking forward to hopefully all the reach out and emails and that we get in response to this.
Yeah, hi there. I could be the second. Hi there. My name is Peter Vai with the work for the Infrastructure Health and Safety Association, IHSA. Yeah, I would like to kind of share some additional information for those of you who may be performing construction operation within a mine. As you can see in the link there, first, IHSA has a safety talks on hand-on vibration that is ready to use. So a supervisor or safety lead can download it from the IHSA website, which is ihsa.ca, or utilize the link that provided in the QR code. And you could deliver it right at the job site. So these safety talks are short, practical, and designed to fit into pre-shift meetings or toolbox talks They cover the key points on vibration hazard and safe practices, so you don't need to create a talk from scratch. In addition to these safety talks, IHSA also offer consulting services. That means you can have an IHSA consultant who are certified visit your site directly to assess vibration exposure in your specific operation. They can help you set up monitor programs, review the tools and work methods being used, and suggest control. They can also assist with custom training session and program development so your company can stay compliant with the Occupational Health and Safety Act. It is also worth mentioning that hand-on vibration exposure can be measured directly through instrumentation, or can be indirectly estimated using a database. One widely used HAV database that available in a German site can give you your exposure value indirectly from any of the common tools. So if you like more detail on how to apply this to your workplace, please give me a call or send me an email, and I would be happy to go over it with you. So that's the general information I would like to kind of share for today. Maybe perhaps another HSA would like to kind of introduce themselves.
Thank you for expanding there on that, Peter. It's great to know that we can do a range of risk assessments for this, all the way from screening up to actual direct measurement and piecing together, hey, this operator works and operates this piece of equipment for this long and this much for this long. Again, we can all build that story and make that assessment as fulsome as it needs to be there. We've got Trevor Shell on the line there as well. Trevor, did you want to introduce yourself and OCal?
Sure. Thanks, Aidan. My name's Trevor Shell. I'm the agronomist out of Sudbury for OCal. Because this is a Northern Ontario initiative, we do have clinics in Sudbury and Thunder Bay. In the QR code, OCal has developed 3 different resources. One is just sort of a quick info sheet on HAVs. So whereas this conference was more on hand-on vibration, the documents OCal's created is more on hand-on vibration syndrome. As Katie mentioned, the disorder that results from exposure to vibration. So we've got a 1-page info sheet, a more detailed booklet, as well as a 3-part video series that just sort of goes over and highlights what is hand-on vibration and hand-on vibration syndrome, as well as prevention measures that can be undertaken. And I just want to thank Steve and everyone involved in this. It's been a great experience. It's not often that we all get to come together and work together on an initiative like this. And it's been a really great experience. And I hope everyone is able to utilize the resources we've all provided and really take an active effort to prevent the development of hand-on vibration syndrome within your workforce. Thank you.
Amazing. Thank you, Trevor. Yes, again, to reinforce here again, using our contact information links in the QR code there at the landing page, or via the emails I'm going to transition to on the next slide. Please do reach out. I know many of you may be thinking that the dollars and cents associated with getting support here, I want to get in front of that and indicate, this is a ministry initiative. We want to provide as much support as possible within the scope of that without having to make any, charges. As much as possible. I can speak to us at WSPS. We are offering complimentary, time-limited complimentary consulting, no-cost consulting for participating in these sorts of initiatives or through Ministry of Labor, Immigration, Training and Skills Development orders or referrals. And again, just to reinforce that all of us want to help you. All of our contact information is available here. I've included the QR code with the link to those resources there as well. And I just want to take the opportunity to hand back over to Steve McDonald to give us a closing here.
Excellent. Thank you, Aidan, for lobbing it over. I want to thank everyone who's attended here today for participating in this webinar and asking some great questions and resources. Katie, you can give me a thumbs up or come off mute. There was another question asked. You did answer it, but I didn't know if you wanted to expand on your answer about the frequency of the vibration waves and how they have any relation and limits.
Yeah, sure. So yes, without going specifically, we definitely did not cover. So that's a great question. We didn't get into how those weighting factors are developed, which ones to use, any of that information for the hand. So the really important part is to note that each part of your body has a resonant frequency. And so that's the frequency at which there's potentially the most damage to the tissue. And so thinking about like a bridge breaking, your bones are not breaking, but there is a lot of movement of the tissue. And that would be those frequencies for each part of your body. That is where all of the human vibration standards, they're all designed around those. And so there is one for the hand where they're very specific to the palm and fingertips, what's happening there. For whole body vibration, it's very interested. It's targeted totally for lower back injury. And then we are currently in development of a foot transmitted vibration specific standard that would be around those frequencies as well. So really important to note that yes, they are totally developed specific to those. So that was a great question. Thank you.
Excellent. Yes, apologies for missing that there. Thank you.
No, that's perfect. Thank you, Katie, for adding that information as well as in the chat. So special thanks to you, Katie, as our subject matter expert at CROSH. You guys are doing some great research, and that was a very informative session you gave us here today. So thank you very much for doing that. Much appreciation to you and to my Health and Safety Association partners, Aidan, Steve, Trevor, Peter. You guys have been phenomenal in piecing this together. So I look forward to visiting with many of the workplaces and finding out that people have reached out and used our health safety partners and adding to the research that's being done here in the North. There's great things happening. Hand-arm vibration syndrome is a serious problem. And I love that everyone's on board to help workplaces and protect workers from the hazard of hand-arm vibration. So with that, you've got about 14 extra minutes left. We're ending a smidge early. Thank you so much. Please reach out to your HSA, to your ministry inspector, or to your regional ergonomist. We're here to help as well. And we're here to assist you, and all the best throughout this initiative. All yours in safety. Take care, everyone. Thanks.